This is a project of collaboration with many institutions from PNRI, UP Diliman, UP Los Baños, University of Leicester, University of Reading, Exeter, and the Physiological Survey. Laterite mining in the Philippines for nickel comprises mining limonite ores and saprolite ores, which are sold mostly abroad unprocessed. And we've discovered recently that they contain also not only nickel, but also important amounts of cobalt and scandium, which are critical metals in the environmental and production of batteries. And the value of the Philippines gets is only about 8 to 18% when we sell the ore directly instead of processing it here locally. One reason of this, of course, the high capital cost of having high pressure acid leaching and the high cost of electricity. In the current processing methods, what is used is basically acids. And if you look at this graph with acids which are basically hydrous, but recently, the scientists have discovered what we call eutectic solutions, which have high ionic content and which might be able to actually dissolve the metals in this laterite ores. If this is used and is successful, it will get rid of smelting and have instead used atmospheric solutions of eutectic solvents. So you get rid of smelters and use deep eutectic solvents. Deep eutectic solvents provide our environmentally benign alternatives, and they're common and inexpensive components like urea, glycerol. And it's potentially inexpensive and could really revolutionize recovery of metals and lower environmental constraints. An example of this is look at this reflected light microscopy of electrum gold. After only a few minutes of iodine, the gold is already dissolved. So we could recover important metals using this deep eutectic solutions, which are potentially revolutionary. Even the Australians have studied this. In a study, they have tried to see also the proof of concept on alternative nickel cobalt laterite ore processing. We are doing our own studies here in the Philippines, and the objective is to use low-cost and environmentally friendly novel solvents in extracting and recovering valuable metals like nickel, cobalt, and scandium, and also to conduct integrated geological studies in the deposit sites. If you look at what's exactly deep eutectic solvents, basically these are solvents that are made when you join two solids, and because of the eutectic conditions, you create a liquid, and that liquid has very high dissolving capabilities, like in this case. And experiments done like Befatelli have shown that you can actually dissolve, like using a hydrogen bond donor, glycol, urea, glycerol, you can dissolve metals extensively. In our study, we will also want to monitor, if we're going to use this at the drill holes, how the solids, rather how the DES travel inside a mine using electrical resistivity, how it affects the groundwater, and so see the effect on environmental and engineering. So theoretically, you could use the solutions in boreholes with an injection well and a recovery well. And in the recovery well, the dissolved metals are already captured. And you can have direct electrolytic reduction to metal from these solids from those boreholes. So like ethylene, DES, and then these are laboratory tests done at the University of Leicester. Copper already is formed directly without smelting. Since nearly 80% of the copper produced, for example, is worth a lot of money, the potential for nickel is there also. So we want to use this even for copper concentrates and avoid smelting, have an impact on mineralogy and environmental responsibility to get rid of smelting and even surface mining. So we need to test the DES, because if it works, it would eliminate surface mining in laterites and extract metals from ores and concentrates, bypassing smelting. Potentially revolutionary for the Philippine mining and processing industry, which would earn us a lot of money. Thank you for listening.